Hello, good day. How are you today? You're good, right? Okay. Are you ready for today's lesson? Okay. So today in mathematics, we are going to be looking at sets. Okay? Set 2. Our topic for today in mathematics it's on sets 2. We have looked at sets before, right? In that video, we just talked about the meaning of sets, set notations, and the type of sets we have. We just did all about talking, right? But today's video, we are going to be looking at set operations, okay? So are we ready for the lesson? We're going to be looking at different set operations, okay? We're with our books and our pencils to get into today's lesson, right? Because today it's going to be about writing. So first we're looking at set operations, okay? Set operations are mathematical operations that involve manipulating or combining sets, which are collection of distinct elements, okay? The common set operations include unions. The union of two sets includes all elements from both sets without duplication, okay? The union is denoted by this. And the union of two sets, like we said, let's say A and B, consist of all the elements that are in set A or in set B or are in both, okay? We're going to be looking at some examples to help us understand what we're saying. Another operation, we have intersections. Intersections is denoted by this symbol. The intersection of two sets consists of elements common to both sets. Okay, the intersection of two sets, set A and B, consists of all elements that are common in both sets A and B. We're going to be looking at examples, okay? We also have complements, which is denoted by this. The complement of a set with respect to a universal set contains all elements not in the original set. Don't worry, we are going to be looking at examples to help us understand, okay? Then lastly, we have Venn diagrams. These diagrams visually represent the relationships between sets. Circles represent sets and overlapping regions show common elements. We're also going to be looking at an example, okay? So first, we're going to be looking at union example first, okay? One of the set operations we're going to be looking at, the first is the union, okay? So we have two sets, set A and set B. Set A contains 1, 2, 3, 4, 5, 6, 7, 8, and set B contains 2, 3, 4, 9, 10, 11, 12. Okay, so remember the union of two sets includes all the elements from both sets without duplications, okay? So we're going to be taking all the elements from both sets. The elements are the numbers inside the sets, okay? Inside the curly braces, okay? So we're going to be taking all the numbers inside both sets, but without duplication now. What does that mean? In set A, we have 2 and we also have 2 in B. We are taking only 1, 2 is not going to be repeated as 2, 2, okay? We have 3 in set A, we also have 3 in set B. It's not going to repeat 2 times, it's just going to be there 1. That is what it means, okay? Without duplication. So the union of A and B is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so the union between A and B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can see that we didn't repeat 2 twice and we didn't repeat 3 twice, okay? Even if they are in both sets. Do you understand? You put it in ascending order also. You don't start from 11 or just start from any number. You put it in ascending order, okay? Good. Let's look at another example. We have 3 sets here. Set 1, set 2, and set 3. In set 1, we have A, B, C, D, E. And in set 2, we have D, F, G, A, C, E. Set 3, we have A, B, E, G, I, J, M. So we have to pick the union between 1, 2, and 3. Remember, the union of 2 or 3 sets includes all the elements. Okay, these are alphabets. Now, all the alphabets inside the 3 sets without duplication. Okay, there is D in 1, there is D in 2. We are not going to write it 2 times because it appeared twice. It's just 1. That is what it means. Okay, so let's pick the elements in the 3 sets. So we have A, B, C, D, E, F, G, I, J, M. You can see we did not pick any of the the letters that appeared more than once. Okay, do you understand? You can pause the video and confirm. Okay, good. So next we're going to be looking at another example under the union also. Here we have the set G and set I. Set G contains 2, 4, 5, 8, 10, and set I contains nothing. It's an empty set. You remember this symbol, right? This symbol means the set is empty. Okay, so this set is empty. What do we do next? There's always a solution. Even if I is an empty set, G contains a set, so it's okay. It's just like 4 plus 0 is still equals to 4, right? It's not 0. 4 plus 0 is 4. So the union between G and I is the set in G, okay? 2, 4, 5, 8, 10. So when you see something like this, even if the set is empty, in union, there's still an element, okay? There's still a set, which is the G, okay? Do you understand? Good. Now the next example we're going to be looking at is the intersection. Remember, the intersection is denoted by the symbol, right? Good. So what did we say the intersection is? Can you remember? The intersection of 2 sets consists of elements common in both sets. That is what we said, right? So let's find the intersection of this set. We have A and set B. So set A contains 2, 4, 6, 7, 9. And set B contains 2, 3, 7, 10, 12. So what is the intersection between these 2 sets, set A and set B? Remember, intersection is the common element in both sets. Here we have numbers, right? So the common numbers in the both sets. We have 2, 4, 6, 7, 9 in set A, and in set B we have 2, 3, 7, 10, 12, right? Set A has 2 and set B has 2, right? So 2 is common. Set A has 4. Does set B has 4? No, so 4 is not common. Set A have 6. Does set B have 6? No. Set A has 7. Does set B have 7? Yes. So 7 is common. Set A has 9. Does set B have 9? No. Set A doesn't have 10 and set A doesn't have 12. So the common numbers between this A and B is 2 and 7. So the intersection between A and B is equals to 2 and 7. Okay? Do you understand? Intersection is picking the common elements. Okay, like we have these numbers as the elements, so it's picking the common numbers. Okay, let's look at another example. Set A has 10, 14, 19, 21, 32, and 35, and set B contains 14, 21, 22, 25, 32, 34, 35. We are to look for the intersection between these two sets. That is the common element, right? And here the elements are numbers. So we are looking for the common numbers. Set A has 10, but set B doesn't have 10. Set A has 14, set B has 14. Set A has 19, set B doesn't have 19. We move on, we keep on looking for the common elements, and we have 14, 21, 32, and 35, right? So the common elements in set A and set B is 14, 21, 32, and 35. So the intersection between A and B is equals to 14, 21, 32, and 35. Do you understand? Do you understand the intersection? Okay, that is good. So let's look at another example. Here we have find the intersection of the sets. We have set C and set K. Set C contains 1, 2, 3, 4, 5, 6, 7, 8, and set K as an empty set. Remember the symbol, right? This represents empty, right? So this is an empty set. So what is the intersection between these two sets? Nothing, right? Remember, intersection is common elements of both sets. Since we have numbers here, common numbers of the two sets, but K doesn't have any element, so there is no common number, there is no common element, right? So the set is empty. Okay, the intersection between C and K, sorry, it's empty. The set is empty because C and K doesn't have common elements. Do you understand? Do you understand that? C and K doesn't have common elements, okay? Okay, so let's look at how to find the intersection for three sets. Set 1 we have A, B, C, D, E. Set 2 we have D, F, G, A, C, E. Set 3 we have A, D, E, G, I, J, M. So we have to look for the intersection for these three sets. And remember, we are looking for the common elements, right? So here it's letters that is representing this set. So we are looking for the common letters. There should be in 1, 2, and 3. Okay, we have A in 1, we have A in 2, we have A in 3. We also have D in 1, D in 2, and D in 3. We also have E in 1, E in 2, and E in 3. So these are the common letters. You can pause the video to confirm. Okay, so the intersection between 1, 2, and 3 is A, D, E. Okay, do you understand that? The intersection between 1, 2, and 3 is ADE. These are the common elements from set 1, set 2, and set 3. Okay? We understood that, right? Good.